Hi my friends, today we discuss about iAssembly. We have to create this unique project even if it seems to be very different. As you can see, this support, the side part, is with some dimensions, here is with another dimensions, and here is with another shape. Yes, but the difference is that here we have a cut, here we have the same cut with other dimensions, and here we don't have the cut because the E dimension is changing, and we can apply cut or not. There are three variants of this assembly: large, medium and small, and they have dimensions here. For instance, E is 80, 60, 30 and so on. You have to observe a special aspect. You see this object, here is once, and here you see three such kind of objects. Yes, their number are here, 1, 1, 3, and of course you can start by creating a draft like this one. Now let's start by creating rapidly the parts. We have here the drawings, yes, 1, 2, 3, because they are different. They come from a unique IAM file, but as you will see, they are different. The names of components are crossbar, side part, and the base plate. We start with the base plate, having dimensions in the table here. Dimensions are H on J, 340 on 60, with a thickness of 10. 10 is at all of them. Good. We start by creating a part in the plane XY, a rectangle centered, 340 on 60. Home, finish sketch, F6, extrude on 10. Okay, then chamfer of 12 on each corner, 12. Okay, steel carbon, and save as base plate. Save. Now we convert it to I part. As we know, a good strategy is to place names. This is H if they can have such a name. This is a unit H, so we have to select H symbol, H S, yes, H underscore S. On J underscore S are the two dimensions. The extrusion itself is not to be symbolized because is the same to all base plates, also the chamfer. Done. Now we convert the part to an I part. You see these two being special, not like D2, D3, are automatically placed here. We use now the table to add the other values. H is also 240 on 60, 180 on 220. So we add two lines, 1, 2, and apply that mentioned values. 240 on the same 60 and 180 tab on 220. Okay. Now there is a table here, yes? If I select by applying double click, I find the other part from the same family, I part. Save as a base plate, yes? Is the name. Next. We save the part as a side part and we convert it to I part. You see dimensions. We have all of them here. So we place that dimensions to the part D, E, D1, E1, D1, E1. You see here is nothing because it will be suppressed to have the other situation of this. So we apply 0 or we ignore also this. Remember dimensions here in this area. Three new rows and dimensions. There are two new special elements to be added. One is threads, the designation, which is the dimension G in our G is metric 12, metric 10, metric 8. The normal pitch is 1.75, 1.5, 1.25 for this. We have to add these values to be a normal pitch. And you see here that dimensions G, G, and G. Yes? Designation is the name of Inventor. Good. We respect this. So we modify with 10 and 150, and here 8 and 1.25. And another thing is with the suppression. We add suppression for this second extrusion, which is a cut. We place it here and we apply suppress at the last. S is enough. I specially ignored these two, D1 and E1, which have the same values as default, because they will be ignored when we select here S, suppress. Okay, and now we have a table, and these three shapes. Good. Next, we save this again, and we go to the next, which is the crossbar. Its dimensions are here. The length is A, these values. The width is B with these values, and the thickness is C with these values. Remember the values. Now we take a look at the crossbar to see some details. As you can see, slots are only at the large variants. Here are two holes placed at the distance f as not slots. So we add holes just in the middle of slots, and this will be an error, and we suppress either slots or holes depending on the variants. Let's do this. Let's apply holes with the diameter of G, which are 12.5 for first, 10.5 for second, 8.5 for the last. Let's create these holes. We start by creating a sketch with a point in the middle of the slot, which means at the distance from here of f underscore s. We know this value on the same horizontal with this point, and then we draw a center line from midpoint to midpoint, and we apply mirror for this point about this axis. Apply. Finish sketch. Now the hole. The hole is not threaded, and it is 12.5, but I want to add here the symbol, our symbol, which is G underscore S equal 12.5. We create a new symbol in this manner. Okay, there are two holes. We receive an error message. Yes, because nothing is modified. The feature as specified did not change the number of faces. The hole is inside the slot. The both are here. We accept this because we know that we create now an eye part. Let's create. We add the other two rows. We change the values here to 40. You know the values: 150, 20, 16, C is 12, 10, 8, FS is 60, 40, 15, and G is 12.5, 10.5, 8.5. And now the suppression. Suppression is for both the second extrusion, which is the cut, the slot, and the hole. extrusion is slot, and hole is hole. We apply S for suppression to the first and S for suppression on slot at this other two. Okay, let's see what happens. We have a table, double click on the second, and there are holes here. Double click and the holes are smaller. Good, that's very good. Let's save again the crossbar, and we finish with parts or eye parts. All of them are eye parts. Okay, now we move on by creating an iAssembly, which will be an eye subassembly. It is based on this crossbar and these two side plates. Let's create this assembly and then let's convert it to an iAssembly. We start by using the IM template and we place the crossbar. We have to be sure that this is 1 because we create the first subassembly from a family, a future family, with the first component in each family. Yes, this is okay. I place this grounded at origin and okay. I don't want to place another one. The next is the side part, which is also the first one to be combined with this object. One is here, the second is here, and then dismiss. Now we constrain this. This is grounded and these are free to be moved. Constrain, aligned this face with this face. Apply. Then this face with this, because we want it to be reverted. Then apply. Then we change the solution to place this here. Okay, move to the left and then constrain this face to this. Apply. And we align the ends of each. Apply and apply. Okay, F6. Everything is constrained. Yes. Now we have an assembly. We choose first in the each family, first component in each family. Let's create an iAssembly, something very new. We use this, create iAssembly. An iAssembly is created by using components. For each component, the representative object is tape place. Crossbar side left, side right. Table we select to be part of our construction. Then table place for the second, and then table place for the last. Good. The assembly 1 is with objects 1. Let's create the other 2 assemblies by selecting the second to the second, the third to the third. The third object in each family to be in correspondence with the assembly. Okay. Good. Now we have a table. Yes? And this is the first. Double click here and we have the second. Double click and we have the third. The third is, as you can see, with distance holes. Okay, we created this, but I have a feeling that this is too long. Let's see. Let's open the crossbar. We open. This is the solution to see. Not double click on the crossbar. Nothing happens if you double click, like in the ordinary assemblies. You use open. I open this and I double click on its table for the second. I'm interested about the second. Yes, this is 240, and as you remember, the second is 2. Yes, 200, not 240. 240 is the base plate. This was a mistake, but we can repair very easy. 200. Tab. Okay. Good. We save this now. We save this as being modified, not open. We save it and we close it. Now we activate the first one, F6, and you remember that the third has 3 objects, this with a distance of 80 in between them. This means that we have to create a pattern, an array of objects. Let's do this. We create 1, 1, or 3. Let's make this. We apply pattern of all these objects in the assembly, linear pattern with the column this, 3 objects at a distance of 80, but with this one in the middle. So we apply middle. This is mid plane. Okay. Now we have another feature in this assembly, but we have to modify this to place this new parameters, component parameter, to be taken as a reference. You see here D9. Yes, D9 is N for us. Cancel, go here. D9 is N underscore S. Yes, because we have to use this parameter in creating our assembly. Okay, we go back here. Now we select parameters and we can see here NS. We take this in attention and we change. This is an unitless. For the first is 1 unit, for the second is 1 unit, the number is 113, and only for the third is applied this new parameter. Okay, double click on the second, is a smaller but also 1. And the third is more smaller, how can I say, the smallest, but in 3 repetitions. Good, this is very interesting. This is our subassembly. Let's make default this one. Double click here and we move on to the big assembly, which connects everything. Save this as a subassembly. Subassembly. Yes, this is a subassembly. Save. Okay, and finish. And now the final assembly. We use the same template and we place the base plate first, number 1, grounded at origin. In this new assembly is grounded at origin. Okay, only 1. And then we place the new subassembly in this assembly, which contains 1, 1, 1, everything is 1. Good. Where to be placed? Somewhere. Okay, dismiss. Now we constrain this because this is fix. Constrain this face with this face. Apply. Okay. And now axis. You know, now our possibility to place them together. The axis Z in each origin to be on the same vertical, on the same line. Okay. F6. This is the first assembly called support. Let's call it support. Support. Save. Okay. Then we create an iAssembly by using the known procedure. Table place for the base plate and table place for the subassembly. In how many instances? In 3. The support 02 with the base plate number 2. This is a part. And with assembly, iAssembly number 2, which is an assembly. The third support with the third base plate and the third subassembly. Good. Okay. Now we look to the end. If everything is okay, we have a table, we have selected the first, and we move to the second. But I didn't save. Now I saved. I save. Okay, my friends. The first, the second, and the third are exactly as the target of this lesson. You see, this is in the center of the slot, and we can see everything as we want it to be. Good. If you want property, I have here update 4.3 kilo for this object, this compound object. Close. That's all for today. Thanks for watching. Bye bye.